Okay, so let's make a start. That's all now for us. So we're going to be starting topic topic 6. Yeah, topic 6. I wanted to make sure I get it right. I don't say the wrong one. And topic 6 is going to be about sequence. All right, and you must have done this in secondary school. We're on topic 6. Okay. You must have done this, a little bit of this in secondary school. Okay, so what do you first need to know about a sequence? Does anybody know anything about sequence? Have you heard the word before? Do you remember anything about it? Everybody's too tired to talk.
I know it, but I don't know how to explain it.
All right. Okay. Okay, so that's good then.
Are you recording the lesson?
Yes, I have. Yeah, it's live. Yeah. So, Abdullah, what is a sequence then? If you know. If you can't explain it literally, you can write it in the, yeah, you can write it in the chat for me. You forgot. Okay, so, right. So you guys write this down for me, okay? You need to know what the meaning of mathematical terms are, okay? A sequence is a set of numbers that follow a pattern.
Miss, can I say this? Can I say that was a sequence?
Yes, tell me please.
The sequence when you actually after the number, you will count it as a number before. Is it that right?
Yeah. So you have that. You have the pattern. Like you have one, and the next one, and the next one.
Yeah.
The next one, and there is a pattern. Yeah.
Yes, the patterns.
Yes. There's a pattern. That's the word, pattern. Yeah. A sequence is a set of numbers that follow a particular pattern. So write that definition down. You never know, you might define it for me in the exams. I'll probably put that in the exams, and some of you will not remember. As I was marking your assessment one now, some of you did not remember half of the things I taught you in the lesson. This is why you need to do your assessment immediately after you finish the lesson. Okay. I'm trying to get both. Yeah. Okay. So that's there now. Okay, you can have, this one's an example, the 2 times table. You have 2, 4, 6, 8, 10, ... Yeah, this is a sequence. Yeah. Now there's another one. What are them? Azem Alad, what are you doing in my lesson? Student, I think he's lost. Okay, so this one is a sequence. If you have it added together, yeah. Then this one is a series, okay? You find them written in books. They call sequence and series. Series is when you add them together, then you have a series. Yeah, but the sequence is just the numbers written down that go in a particular pattern. Yeah, every sequence has a rule. Ooh, goodness me. I'm sorry, guys. This digital pen is so difficult to manipulate. Yeah. So every sequence has a rule. Yeah. On this one now, if you have a look at this one, from 2 to 4 is adding on a number. What's the number that is adding on each time?
2.
2.
It's adding 2. It's adding 2. It's adding 2. Each time it's adding 2. So the rule for this one is adding 2. Yeah. For this one is adding 2. How about this sequence? 3, 5, 7, 9, 11. What's the rule for this one?
Also adding 2.
Adding 2. Yeah. Okay. So there are a couple of things that you need to know when you're working with sequence. Okay, you need to know what the rule is. You need to know how to find out what type of sequence it is. There are so many different types of sequences. Okay, and the main one that we're going to be doing for today's lesson especially is how to find the nth term. Yeah, the nth term. And you know what the nth term is? You know what the nth term means or is? It's a term, any term in the future of that sequence. Yeah, any term along the line of that sequence is any term further along the line of that sequence, okay, that you can find using a particular rule that you have for that sequence. Yeah, once you know the rule for that sequence, then you can find any term, and we call that any term that we can find the nth term. Yeah, so let's go to my maths and let's have a look at what they have to say about sequence and what we can do, maybe 1 or 2 activities on there that we can have a go at. I did open it this morning. Where is it now? Oh, yeah, okay. New share, my maths share. So you guys, I always tell you when you're doing your homework, take your time, make sure you go back to the lesson. You don't have to watch the whole thing, but try and watch the parts where I'm explaining the problem, how to solve that problem, so that when you come to do your assessment, you can do it properly and you can get the marks. Your module is important, as you know. Yeah, you pick up some marks from there and you pick up some marks from the exams and some marks for your participation and all the other things. Okay, so I've already told you, each number here is called a term. Okay, so 3 is a term, 5 is a term, 7 is a term. They are all terms. And the nth term is the term that is further along this sequence that you can find if you know the rule. Yeah? It's adding on to each time for this sequence. Yeah, so the common difference, yeah, 2 is known as the common, so you need to write that down for me, yeah? 2 is known as the common difference. Two is known as the common difference. You need to write that down for me. And once you know the common difference, you can use that to help you find the next term in the sequence. Okay. So here you've been given a sequence, yeah, the rule or the nth term. Here you've been given the nth term of the sequence, and you've been asked to find the first 5 terms of the sequence. How would you solve that problem? How would you solve? How would you find the first 5 terms of this sequence that has this rule 3n plus 1? Yeah, this is called generating the sequence. Oh, somebody's coming to my door now. Give me a second, guys. Thank you. Okay, so if it says generate the sequence, if it says find the sequence, then you have to remember the first term, the second term, first, second, third, fourth, and the fifth term. Yeah, find the first 5 terms, and all you have to do now is to substitute 3 times 1 plus 1, 3 times 2 plus 2 for the second term, 3 times 3 plus, plus 1 here, plus 1 for the third term, 3 times 4 plus 1 for the fifth term, for the fourth term, and 3 times 5 plus 1 for the fifth term. So what it means is anywhere you see n, replace it with that term. So the first 5 terms, the first term would be 1. The second term would be n would be 2. The third term n would be 3. The fourth term n would be 4. And the fifth term n would be 5. Yeah? So the first term here is 3 times 1 is 3, add 1 is 4. 3 times 2, 6, add 1 is 7. 3 times 3, 9, add 1 is 11. 3 times 4 is 12, add 1 is 13. Oh, this is 10. Yeah. 3 times 5, 15, add 1 is 17. Yeah, so you see, that's how you do it. 4, 7, 10, 13, 17. Yeah, so write them down. So that's one way that you might get a question. It might say, find the first 5 terms of the sequence. Yeah, the question might say, find the first 4 terms of the sequence, and it will give you the nth term. Yeah, it will give you the nth term, which is like the rule that you use to find all the terms. Yeah, find the first 5 terms of the sequence. Okay, let's have a look at what they have to say. Yeah, the expression 3n plus 1 is simply a way of working out what each term should be if we know where it lies in the sequence. Yeah, the first term, the second term, the third term, the fourth term, and the fifth term. So this is the nth term. Yeah, the nth term gives you the rule on how you work out all the individual terms. No matter what the term is, you can use it to find the 100th term, the 1 millionth term of that sequence. So we've already done them. We've already done the substitution. We already know how to do it. Yeah. Okay. Now you guys, yeah. So an arithmetic progression, this is the problem with my maths. They just jump to another topic without giving any. An arithmetic progression is a progression, is an arithmetic sequence is a sequence with a common difference. Yeah, a sequence that has a first common difference. So some sequences would have a first common difference. So it's adding to each time, adding to. Yeah, but some other sequences don't start off with the first common difference. They'll start off with another pattern. Then you do that pattern first, maybe +3, +5, plus 7. Before then you come to the second one, then it's adding 2 each time. Yeah, on the second difference, it's adding 2 each time. You have the first difference and the second difference. Yeah, you have a common difference. These are all common difference. Yeah, so for an arithmetic sequence, you only have a common difference straight up on the first difference. Yeah, so let's have a look at these ones to see which ones have a common difference the first time. Do you guys think this one would have a common difference the first time? 1, 3, 5, 7. Let's subtract. Let's see what this is adding to. This is adding to, and this is adding to. So yes, this would have, yeah. Okay, so that one says all right. Yeah, and how about this one? Check this one. What's the difference each time? 0.5. Yeah, and here 0.5, and here 0.5. So do we think it's an arithmetic sequence? Yeah, let's try. Let's see. Yeah. How about this one? Question 3. Let me put numbers on them. 1, 2, 3. Do you think question 3 is an arithmetic sequence?
No.
Yeah, let's have a look. We have 2, we have 6, 18, 54. Yeah, between this and this, there's a difference of 4. Yeah, and between 6 and 18, there's a difference of what? Is it 9 or 10? No, 11.
12.
12. And between 18 and 54, what's the difference? 40. Is it 40?
36.
36? Yeah, 36. Yeah. 36. So that's not common. So that's not a common difference. So we're not going to go with that one. So it's marked us wrong on that one. So we're right. Yeah. Okay, so we got the gist. Find the first 5 terms of this first sequence. Have a go at question 1 for me, guys. Well done, Naji. Yeah, well done. So you must know how to do your substitution 2 times 1 plus 6, 2 times 2 plus 6, 2 times 3 plus 6, until you get to 2 times 5 plus 6. Yeah, and finish that up quickly. 1 or 2 more to finish.
I finished, teacher.
Well done. Hamad, have a look at your third term for me again. Yeah, your third term, this one. Well done. Well done, Ali.
Which one, teacher?
You know your question 1 that you submitted. Have a look at, you had 8, 10, and have a look at the next one. Put it back in your calculator and check it again for me. Well done, Reem.
12.
Well done. Yeah. Okay, so you guys, you got that one. That one is 8, 10, 12, 14, 16. Well done. Okay, so how about the next one then? Have a go at the next one for me. Substitution. Quickly, you need to know how to substitute. You need to be an expert on substitution. And sometimes once you see the pattern, you can just do it. Yeah, okay, well done. The answers are coming in. Well done to you guys. So 8n minus 3. So you should have your first term should be 8 times 1 minus 3, 8 times 2 minus 3, 8 times 3 minus 3. Yeah. Well done to you, Ali. Well done to Abdullah Aloud, and well done to you, Reem. Okay. So you guys, I think you know how to work out the terms now, yeah? The main thing that we need to know how to do is to find the nth term. Okay? The main thing that we have to know how to do is to find the nth term. So I'm going to take you back to my whiteboard and show you how to find the nth term. Let me write down that sequence. Let me see. I'll choose 1 or 2 sequence, the ones that we said were all right. 3, 7, 11, 15. Yeah, let's choose that one. And let's see whether we can work out the nth term for that sequence. Okay, so let's say we have the sequence. We have 3, 7, 11, and 15. And we've already found out that we have a common difference of 4. It's adding 4 each time. Here, 4, here, 4. Yeah? So we know it's going to be 4n. Yeah, it's going to begin with 4n because we're adding 4 each time. The common difference is 4. So now we start with the first term. 1, 2, 3, 4. Yeah. For the first term, we have 4 times 1, which is equal to what? 4. Well, how did we get this first term here? Have a look at 4 on this. What did we do to get this 3 here?
-1.
We did 4 minus 1. Yeah. So we've done n minus 1. Yeah. So look at the second term now. 4 times 2. 4 times 2 is 8. But have a look at our second term here. What do we have on the second term?
8 minus 1.
8 minus 1. Yeah. So what's our nth term going to be then? 4n, which is what we are getting here. 4n minus 1. Okay, 4n minus 1 is the sequence for that one. Well done, Abdullah. Yeah. So that's how you work it out. Okay. So you just have to draw that table and then make that comparison. Yeah. 12 minus 1. 4 times 4 is 16 minus 1. Yeah. So here you have 4n minus 1. That's the nth term. Make sure that you've written that down. And then we can go back to my maths and see if we can try out some of them that they have on my maths. Yeah, you know how to do it. First step is to find the common difference. Once you got that common difference, you know that the nth term will start from the common difference times n, then plus or minus whatever the difference you get here. Okay, right, let's go back to my maths and have a look at some questions. Was it on slide 6? Slide 8. Okay, so can you guys find the nth term of question 1 for me? Find the nth term of question 1. Yeah. Well done to you, Reem. Yeah. Ooh, you have to write that correctly. You have to write it completely, okay? You have to work out the difference. So here, let's do it together. So you had, let's work out the common difference first of all. Here is it 6? We're adding 6 here, and here you're adding 6, and here you're adding 6, and you're adding 6. Each time you're adding 6, yeah? So you know it's going to be 6n. So now you got to make that table. You got to make that table, follow the steps. When I'm marking this, I'm going to be checking, did you write your common difference down? Did you make the table or did you follow the steps? Yeah. So for the first term, we have first term, second term, third term. You don't have to do it for all of them. Once you do the first 2 or 3, you get the pattern. 2, 3, 4, you get the pattern. Yeah. So then you have 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. And 6 times 4 is 24. Well, how did we end up with this one? So you make the comparison. So this would be 6 times 1 plus 1. Yeah. So it's adding on 1. The next one, 6 times 2 plus 1 plus 1 plus 1 each time. So it's going to be 6n plus 1. Okay, so have a go at the next question for me, guys. I need to see your sequence, your nth term written properly like an nth term. Yeah, we got that one. So have a go at the next one. Okay. Good, well done. So you guys are enjoying this topic now. Good, well done. So let's try the question 2 now. Here, 5 subtract 2 is 3. So we're adding on 3 each time. Yeah. So we know it's going to be 3n. Yeah. So now let's work it out using the table. Nice topic. Yeah. So let's work it out using the table. 3. Yeah, how did we get from? So the first term we have 1, 2, 3, 4. Yeah. For the first term we have 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So the first one here is 3 minus 1. Yeah. 3n minus 1. This is 6 minus 1. And this is 9 minus 1. And 12 minus 1. So it must be 3n minus 1. Okay. Question 3, guys. Quickly. Now, this is primary stuff. We're just catching up on the primary stuff. We're just catching up on the primary stuff before we go to the real deal. Huh? 5n plus, oh, okay, we'll see now. Have a go at this one. What's he adding on each time?
5.
Yeah. So it's going to be 5n, yeah? So now you need to make that comparison. You need to make the comparison. My geometry, oh, my algebra folder. Oh gosh. I think I have sequence in here somewhere. geometry. Make sure you know how to do it. You can get it. It can be tricky sometimes. Yeah. So the first term is 0. Yeah. So 1, 2, 3, 4. Yeah. 5 times 1, yeah, is 5 minus what gives us 0? Minus 5. None of you got it. Oh, some of you got it. All right. Okay, well done. Some of you could say the 0 and 1 and all that. 5 times 2 is 10. 10 minus 5 is 5. Okay, so you need to watch out for that now, because they can put some sneaky ones and you'll get confused. You won't know what to do. So it's 5n minus 5, the last one. Let's check it out. Yeah, so that's this one. Okay, have a go at the last one, guys. Okay, somebody's got it already. I don't know what it is, but we'll see now. Okay, well done to you, Ali and Abdullah. We'll see whether your answers are right or wrong. Okay, you have to find the common difference. What is happening each time? Okay, well done. It's adding 3 each time, yeah? So plus 3, plus 3, plus 3, plus 3. So it must be 3n. Okay, so let's do it for the first term, second term, third term, and fourth term. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Okay, how do we end up with these ones that we're getting now? 3 times 1 for the first term, we have 6. Yeah, negative 6. How did we get to negative 6 from 3? So negative 6 is here and 3 is here. Yeah?
Minus 9.
Yeah, that's it. So you got 0, got 2, 1, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. So you have to keep on going back. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's negative 9, yeah? So it's 3n minus 9. So well done to you guys that got it right. Well done. Okay. Let's see if we got it right now for good. 3 times 1 plus minus 9. Well, so we got them all right now. And this page is usually a rubbish page. But I'm going to, because I always ask questions, but this time I'm going to get you guys to tell me which number on the screen I need to drag the first term or drag the nth term formula onto the first term in the sequence. Yeah. So I have 2n plus 3. What's the first term going to be? Who is going to do that one for me? Let me see my participants. Somebody that hasn't said anything today. What is Azem doing in my lesson, for goodness sake? Who is using Azem's account? Are you doing further maths now, Azem? I'm sure he just put it on and walked. He thinks he's in foundation maths. He put it on and walked away. All the students. Oh, these students. I'm going to remove you. Oh my goodness. He thinks he's in foundation maths, so he just came in and put it on and he's going to do his business for the day. Oh, goodness me. All right, so who is here? Who else is here now? Khaled Alotaibi, that's your question. Okay.
Okay.
Hang on a minute. Let me find it. Where is it now? So what's the first term on this one here? I'm going to circle it. What's the first term on this one? We have time to play game. Let's play. Biggest link. What's the first term? I'm in trouble. If Khaled can't do it, I'm in trouble.
Miss, is it 5?
5.
It's 5, yeah. So if we drag this to 5, where can I find 5 now? Yay, so that's the sequence there. Okay, that's the first 5 terms of the sequence. Okay, Reem, this is your question. What's the first term of this sequence?
One.
Okay, do we have 1 there? So should I drag this to 1? Where can I find 1 now? Is it this one? Is it this one? Nope. Is it this one? Nope. Is there any other 1 here? 3 times 1 is 1.
Down next to 10.
Oh, there we are. Is it that one? Yeah, well done. Okay. Hamad, this is your question, okay? What's the first term of this sequence? Abdullah allowed. He said the game is harder than the topic itself. Yes, so funny. It's not hard. Abdullah allowed what? Hamad. God, Abdullah allowed. You put your name in my mouth now. Hamad, what's the first term of this sequence? Okay, Abdullah, you need to help Hamad. What's the first term of the sequence? Is it 4? Okay, should we try? Is it this one here? Nope. Is there any other 4? Is it this one here? Yes, it is. Well done. Okay. Who else is here? Naji. This is your question. This one. No. This one. This one is your question. Right. What's the first term of this sequence?
-5.
-5. Okay, let's check. Is it this one?
The second line.
This one? Yep. Oh, well done. Right. Who else is here? Is Ariam here? Oh, Ali, this is your question. Yeah. So this is yours. What's the first term of that sequence?
It's -4.
Is it -4? Okay, should we have a go? Let's have a, where's -4 here? Is it this one? Yeah, well done. Okay, it says, drag the end term formula onto the first grid in the sequence hidden in the grid. Okay, the first term in the sequence hidden in the grid. Yeah, okay, so who else is here? Let's have a look. Ariam, where's Ariam? No Ariam. So Naji has answered. Abdurrahman Alanzi, where are you? You are hiding in the background. This is your question. What's the first term of that sequence? No answer. Okay. Abdullah Aloud, help Abdurrahman, please. Three, yeah? Okay, let's see.
Down.
Here?
Mm.
This one? Let's
Yeah.
try. There's another one here. Yeah, well done. Okay, Naji, this is your question.
Can I try, teacher?
Oh, Hamad, you want to do it? Go ahead then.
Yeah, this will be -3 and 0 and 3.
-3 and 0. How can it be 2? Which one do you want to go with? -3 or 0?
-3.
Okay, should we try? Let's have a look then.
No, down. Yeah, left.
No.
Up. Here, yeah. Yes, -3.
This one?
No.
Oh, -3. Oh,
Yeah.
well done. Sorry. I could not see. Okay, right. Who wants to have a go at this? This is a simple one. Everybody should be able to do this one. I can even see the pattern there.
It's one in the first line.
Yeah, it's on the first line. I can see it. Who wants to do it? Go on then, you guys. Okay, Rim, can you finish it off for us? Last one.
2.
2? Okay, let's have a go. Is it this 2? No. Is there any other 2 somewhere?
No, 2 and 6 and 10.
Is what?
No,
What?
in the second line.
Oh, here?
Yeah.
Oh, there we are. We finished it at last. Oh gosh, at least we had something fun. Not just crazy. Okay, well done, guys. At least all of you know how to find the terms now. The first term, and you can see the patterns, so you played with it enough. So let's go into some proper stuff, all right? This is too much playing now. Okay. or n term for quadratics. Okay, so write down now the finding the nth term for quadratic sequence. So you have this sequence, yeah? You have this sequence. And when we try to work out the common difference on this one, here is adding 3, but here is adding 5, and here is adding 7, and here is adding 9. Yeah? So you can see that it's different each time. So the first difference, we have a first difference. Yeah. So now, based on our first difference, let's try and see if we can work out a common difference from the second difference. This one is adding on 2, and this one is adding on 2, and this one is adding on 2. Yeah. So this type of sequence is called a quadratic sequence. Yeah. So make a little sketch of what I've written on the board. You have the second difference. You have the common difference on the second difference. It doesn't happen on the first one. It happens on the second one. So it must be a quadratic sequence. And you know what quadratic means? It means you have squared. You have x squared somewhere. Yeah? Because you've been playing with maths with me for how many months now? So now you are a master of all these things. Yeah. When your younger ones give you their homework to do and they're crying, you'll be like, how come you can't do this simple thing? Huh? Oh, goodness me. Yeah, I was looking for my here. So if you've written that down, then let's move on to the next. I'm going to clear all my drawings. Okay, notice that it doesn't increase in equal steps. It is not linear. Yeah, it's not linear. We haven't come to the answer yet. Let's go through the lesson one after the other, okay? We have 3, 5. Yep. Second difference. The second difference is 2. We have a constant second difference of 2, which means it's going to be a quadratic sequence, okay? The n term formula will contain an n squared, okay? It's going to contain an n squared formula. Let's have a look at the second slide. Now have a look at this sequence again. Let's see what's happening on this one before we go through the lesson. This one is adding 3. Oh, it's the same one we just saw. Yep, it's that same one. So what have they got to say? Yeah. Yeah. I have taught this on Mass Junction, but because I'm streaming on Mass Junction, it's going to give me a problem if I try to, hang on a minute, I'm just gonna check it on my app here now. I don't like how they've explained it there. I want to explain it my way. Videos, quadratic sequence. Oh. Sequence. Okay then. Yeah. So we're still doing the kind of comparison thing here. Yeah, we're still doing the comparison sort of thing. So you know it's going to be x squared. Yeah. But then you're comparing the x squared. The first term would be, oh, right. The first term would be 1 squared. The second term would be 2 squared. The third term would be 3 squared. The fourth term would be 4 squared. Yeah. So you have 1 for the first one, 4 for the second one, 5 9 for the third one, and 16 for the fourth term. Now you're going to look at your sequence, the sequence that you have, and make the comparison. Yeah. What's the difference? What's happening? Now first term, it's -3. Yeah. Yeah. 4 minus 3. Our second term is 1 plus 3. Yeah, plus 3. Yeah. And then our second term, which is supposed to be 4, is 4 plus 3 to give us 7. Yeah. And the next one, which is supposed to be 9, is 9 plus 3 to give us 12. And 16 plus 3 to give us 19, and so on. Yeah. So we are still doing the same comparison. Yeah, it's just that I'm used to setting up my table this way, so it's easier for the students to see it. So let me write that out clearly for you guys so that you can see it. So this sequence is 4 9 4 4 7 4 7 12 19 28. Yeah. And you know it's an x squared term because you're having a common difference on the second difference. So it's going to be x squared. Yeah. So or n squared, however you want to call it. So our first term here is 1 squared. Yeah. And 1 squared is equal to 1. How did we get 4 here? Is 1 add 3. Yeah. Our second term is 2 squared. 2 squared is equal to 4. How did we get 7 here? We added 3. So just like that, you can make a list table if you want. And for the fourth term, so you can write terms, and the fourth squared is 16. 16 add 3 is equal to 19. So leave it there. I don't know why I'm scribbling on there. I could have just erased it.
I think I didn't understand this one.
You don't understand this one, Khaled? Oh my goodness. We're going to do another one now, okay? This is why I told you that it's not good to be too involved in the playing of the game. You will forget that it's maths. Oh, okay. We'll do another example now and you will understand it, okay?
Okay.
So let's go to my whiteboard then. Share screen. So let's say we have this. Oh my goodness, I broke all my glasses. The glasses I just got. It's broken. Oh my God. Look, it's broken.
It's okay, teacher.
Oh gosh, I can't wait for this whole thing to be over. I'm so tired of the stress. Okay, right, I'll just put that to the side. I have to go back to Specsavers. This is crazy. Now I have no eyes anymore. I only used my eyes for how many weeks before it got broken again? They would have been tired of me in Specsavers by now. Okay, so let's say we have this one, 2, 5. I don't know if this one is quadratic, but you let me know whether this one is quadratic or arithmetic. What's this one?
No, it's normal. It's add 3.
Oh, it's adding 3, so it's arithmetic then. Okay, how about this one then? 6, 15, 28, 45, 66.
I think the first one is 9.
Yeah. So this one is what? 6 add 9. 15 add what is this?
13.
And 28 add 28 add what is giving you 45?
17.
Add 17. And so this one is all different. And what's the difference on this one? Add what?
21.
21.
Okay. So are we going to have a second difference? So we got a first difference. Let's see if we can get a second difference. 9 add what is 13? 9 add
4.
And are we adding 4 on this one as well? Yes, we're adding 4 here as well. So this one is a quadratic sequence. Yeah, it's definitely going to be quadratic because we are having a second difference. We're having a common difference on the second difference. So we know that it's going to be n squared. Yeah, it's going to be n squared. It's not going to be 2n, it's going to be n squared. Now, this difference, quadratic means you have squared. Yeah? Quadratic means n squared. It's not going to be 2n, it's not linear anymore now. It's curved, it's squared. Yeah? Okay, so we have our first term, we have our second term, third term, fourth term. By the fourth term, you should have known, so I don't usually waste my time after that. So the first term is supposed to be 1 squared, yeah? Because you're using this formula, 1 squared. 1 squared is equal to 1, yeah? The second term should be 2 squared,
4.
which is 4. And the third term should be 3 squared,
9.
which is 9. And the fifth term should be
16.
14, 4 squared, which is
16.
Yeah. That's confusing now. Yeah, 16. Okay. Something just happened to me, like a moment I had where should we be doing something with this 4? Yeah. Do you understand? Okay. We're fine. So now we need to make that comparison. What's the first term? First term is n squared plus 5. Yeah. Second term is n squared, which is 2 squared, no, 4 plus, no, that's not right. No, that's not right at all. Yeah. Because here we have 6. So here we have 6. So it worked for the first one when that was 2, but now it's different. Here we have 15, we have 28, we have 45. Right. Wait a minute, guys. I said we had to do something with the common difference. plus 4. Oh, right. 1 squared plus 3 is equal to 4. Okay. Did I explain that right to you now? 1 squared plus 4. 1 squared is 1 plus 4, but that doesn't make... Go back to my maths. Stop the share. This is getting really confusing now. So that's the one we're working with. These are the term numbers, yeah? These are the squares of the numbers. Yeah, I was looking for my lesson video and I couldn't find it. And I forgot how I explained this the last time. N squared, yeah. 3 more. So it's always going to be 1 squared plus 4 then. But it doesn't work for the first term. Let's go back.
So it will be plus 4.
Yeah, it's supposed to be plus 4, but does it work for ours? Yes, let's see. Does it work? 1 squared is 1. Plus 4 is 5, so that doesn't work. 2 squared is... What is 9 plus 4? Yeah. So that doesn't work, my maths. 2 squared is 4. 1 squared plus 4. Because of this. But yeah, but that's what they... Yeah, okay. I give up. Let's try another one and see. But that is a different... let's try this one. Maybe I'm using... Because I'm using one from my textbook, my book here. The one that I put. Let's try this one and see. So if we go by this one, we will have why is it not letting me? I want to annotate. Okay. Stop share. New share. Yeah. So this is what 3, and this is what 5. So these are giving you 2s, and this is 7, and this is 9. So this is going to give you 2. So you end up with a difference of 2. So that is n squared plus 2, is it? 1 squared plus 2 is 3. 2 squared plus 2. This one makes sense. Yeah, is 6. 3 squared plus 9 plus 2 is 11. So this one makes sense. I think that rule, maybe we're working with this thing that is not quadratic. Yeah. So maybe that's the problem we're having. So let's try. You guys try the next one. Nth term is n squared plus 2. Mark it. Yeah. So have a go. Use the method I've just shown you to try this one, question 2. Yeah. Try.
Miss, can you do question 2? I have no idea.
Okay. So you know it's quadratic, right? The first step is to determine whether it's arithmetic or quadratic. Yeah. So if it has a second difference, then it must be quadratic. So this is adding 3 each time, plus 3. Oh, plus 4.
No, it's
plus 5.
Yes.
Plus 7, plus 9. Yeah. So then you would have 2's. Yeah. So it's going to be n squared plus 2. Is it? I don't know. Let's try it. No. N squared. Where's the at? Plus, is it plus 2? Well, n squared plus 2 is going to give you this sequence. At what point? No, it's not right. At what point do you And what do you do with the numbers? This is so confusing. I'm so sorry, guys. What do you do with the numbers now when you make the comparison? So this is n squared plus 2 is equal to for the first term, we would have 3. 1 squared is 3. 3 add 4. So what's that going to be?
Three and 4.
No, I have to look for I'm sorry, I'll teach you guys tomorrow, okay? I have the lesson. I definitely do, but I just can't find it. I just can't find the explanation for that. That's so messed up. Seriously. Now I'm going to explain it to you guys tomorrow. I'm going to get my head around it. So confident.
Teacher, it's not n square plus 2?
What is it?
Or number 2?
I think miss it's n squared plus 3.
Is it? Should we try 3? It's not 3 then. Should we try? No, it's not. Yeah, but you see the explanation. Look, have a look. So that's the first term, 4, 7, 12, 19, 28. Okay, so when you square, the first term is going to be 1 plus 3. Yeah, second term is going to be 4 plus 3. The third term is going to be 9 plus 3. Yeah, so it's plus 3. But what was the common difference of? So guys, let's go back. No, we have to follow this method and get this. We should be able to do this. We should be able to do this now.
That's right.
Yeah, we'll write it down and then we follow it and do it and see what we're doing wrong. 1, 2, 3, 4, 5. 1, 4, 9, 16, 25. So 3, 3, 3, 3, 3. So it's n squared plus 3. Yeah? Have we written it down? This topic proved to be looking easy, but proved to be difficult to explain now. Okay. Was it the first one or the second one that was giving us problem? 3, 6, 11, 18, 27. We did that one. So the first 10, second, 13, 14, and the fifth 10. 1. 1 squared, 2 squared, 4, 3 squared is 9. 4 squared is I see what we're doing wrong. 16. That's good. Is we're comparing the squares, not the okay. 25. Okay. So is is 2. 2. 2. 2. So this is n squared plus 2. Yeah, the first one is n squared plus 2. Let's have a look at the second one. I'll check it. N squared plus 2. Yeah, that's straightforward. Second one that was giving us headache. 5, 8, 13, 20, and 29. try n squared plus 4? Yeah. Okay. So let's go back to my, yeah, so it's, go back to my whiteboard.
Why is it 4?
Why is it 4? Because, you know, when we put the, we need to do the subtraction. We need to, we need to use the difference. Where's my whiteboard? Stop share. Let's go back to my whiteboard. Yeah, so this should have been n squared plus 4. Yeah, actually. So if it's 1, it's 1 squared. But that, I don't know why this wasn't a quadratic sequence. I think this was a wrong one that we were using anyways. But the main thing, if you were to use the one that is on the my maths now, yeah, let me use that one and explain it to you. So you have it's 5, 8, 13, 20, and 29, yeah? And you know it's a quadratic sequence because you've done the first difference and the second difference. Yeah, you got the second difference to be 4. You got this one to be 2. So we were worried, we were looking at this one, but we don't need to look at this one anymore at this point. Once you've confirmed that it's a quadratic sequence, yeah, you finish with that, you leave it. Now you need to write the quadratic, you need to write the square numbers, yeah? You need to write the square numbers 1, 4, 9, 16, and 25. And you need to take the difference now, yeah? You need to check the comparison is between this one and this one, yeah? 5 minus 1 is 4. 8 minus 4 is 4. 13 minus 9 is 4. 20, is this 6? Yeah, minus 16 is 4. 29 minus 25 is 4. Yeah, so then you know it's n squared plus 4. Okay?
Okay, I understand.
Now it's clearer. I think we were messed up with the first sequence that we put up there was kind of messed up. It's one of those days. Oh my goodness. So should we have a go at one more before we leave? No, miss. That's enough for the day.
Yes, teacher.
One more before we leave.
It's okay, teacher. Take your time.
No, let's do one more.
It's okay.
Okay, tomorrow we have a bit more practice, all right? Thank you so much, guys. Well done for your hard work, and I will see you all tomorrow, okay?
Yeah, we will work hard.
Yeah.
Thank
all
you.
right.
Have a good day.
And you. Bye.
Thank you, miss. Have a good day.
Bye. And you. Bye.